Okay, in this third video, we're going to get into sampling methods. So when we talk about sampling methods, let's first take a step back and understand that when we were comparing a population, we were talking about every possible unit that addresses the research question that we're interested in. And so we realized that it's just not feasible to be able to measure every possible unit in the sample. So instead, we're going to have to use what's called a subset of the population called the sample, and we're going to measure it in those folks. But the real question, what this video is all about, is how do we sample people from the population? And so this is where I want to introduce you to the term that's known as error. And we have this thing called sampling error, which is a difference between the sample value, or the statistic, and the actual population value, which is a result of normal random sampling variations or fluctuations. So for example, when I recruit a given sample from the population of interest and I collect data on that sample of individuals, how do I know that that sample of individuals actually is truly reflective of the larger population? And so sampling error merely states that the sample of people that I recruit randomly from the population may not be the perfect representation of the population of people that I'm trying to infer about in my study. In a non-sampling error situation, we're talking about things that are within the locus of control of the researcher. So we're talking about differences that we see in the data in the actual population that's because of something that we did wrong or something that we just didn't see as a researcher. So for example, somebody that collects data and incorrectly records the data, right? So somebody who, instead of typing in a blood pressure of 120, they type in a blood pressure of 1200. Well, clearly a 1200 blood pressure is not reasonable, so that's an error. And if we don't correct and fix that data, all the numbers that we calculate for the rest of the term are going to be thrown off. So we have to be able to have processes in place to check for those things beforehand. Another thing that happens is sometimes people incorrectly analyze the data. Later on in this lecture video series, we're going to talk about how you know what statistic to choose when it comes to answering a particular research question. But sometimes people pick the wrong statistics, and that throws off their data, which makes it less trustworthy. And then the third thing is what's called biasing the sample. So for example, if I'm really trying to generalize information from a population of interest, I really should be randomly selecting the people from that population into my sample. And so that means that every single person that's in the sample should have an equal opportunity of being selected from the population. But we know oftentimes in research that sometimes people will collect data based off of people they happen to have access to. And so when that occurs, that's what we call a non-random sample, okay? Because people are now having preferential treatment who meet a researcher's inclusion criteria, but is not randomly being selected into that population, which is a problem. So when we talk about random versus non-random sampling, in a random sample, every person from the population has an equal opportunity of being selected for that sample in that research study. Whereas in a non-random sampling study, each person in the population does not have those equal opportunities to participate. So these are some of the ways in which researchers will go about sampling and getting the people they need for their research study. So for example, in a systematic sampling procedure, the population is arranged in some type of sequential order, for example, by age from youngest to oldest, and then a researcher will pick a random starting point in that group, and they choose every 12th person. So let's say a researcher is looking at a phone book, which might be dating myself a little bit, but let's say they open up in the phone book as an alphabetical order, and let's say the person just happens to open up a random page in the phone book, closes their eyes and puts their finger on a particular person, and they say, okay, we're going to pick every 12th person from this point forward. So they start counting and then they get to the 12th person, and that person is in the study. And then they move on to the 24th person or the next 12th person, and then that person's invited to be in the study. That's a version of what we call systematic sampling. In convenience sampling, what happens is the sample of individuals are selected from people who the researcher already has access to. So for example, in some of my research studies, I may recruit people who are physically active. So I might choose to go to the DAC, which is a fitness center we have here on campus, to ask students who go to the DAC if they would be interested in participating in my study, because my study is all about people who want to participate in physical activity and exercise programs as it stands. So in a convenience sample, instead of trying to randomly find the exercisers on campus, I could just go directly to the DAC where I know people are going and using the facilities and they're already exercising. So I have access to those people. It's convenient. I know the people at the DAC, and they allow me to recruit from their membership. So that's what we call convenience sampling, where you have a strategy to find the people that meet your inclusion criteria. But again, you're creating a situation which is not reflective of all people from the population who really could meet that criteria. So they have a more preferential ability to be in the study because they find out about it sooner compared to other people, let's say at the University of Penn, or even, let's say, West Philadelphians in general who are exercisers that would like to be in the study. They might not learn about it for several weeks or months at that point. Okay, then we get into what's called stratified sampling. And in this particular case, the population is going to be divided into different groups or strata, and then there's going to be randomization that happens from there. So for example, if I was doing a research study, one of the things that I know for certain is that in the United States, the population is roughly 60% biological female and about 40% biological male. So I could easily just have a random 50-50 split, but that's not really reflective of what the sex distribution is in the United States. So I could do something called a stratified sample, where I deliberately have 6 or 7 out of 10 of the participants in the study be a biological sex of female, and the remaining 3 or 4 make sure that those are reserved for people who are biological males. So in that typical situation, you have the stratified based off of groups, and then you randomize among those groups at that point, right? So there's still randomization, but you're doing it with some level of control as the researcher. And then lastly, we have something that's called cluster sampling. And in this case, the population is going to be divided into different clusters based off of geographical regions, for example, or some other metric. And then we randomly select from the cluster. And so in particular, what may happen is you can have, for example, a lot of times in voting sections, right? So for example, when different political polls come out, you may want to understand which candidate is leading in the political race based off of geographical locations, based off of different political, I guess we can say higher percentage of people may vote for one particular candidate compared to another candidate in different parts of the country. So if you wanted to do a poll, let's say in Philadelphia, you would be able to identify the city of Philadelphia, which is in the mid-Atlantic states, and you would be able to get a representation of what the voting is going to look like for a particular candidate or set of candidates based off of how a sample of people from the mid-Atlantic states votes for those particular candidates. And we can extrapolate what that would look like in the larger mid-Atlantic states. Similarly, you would be able to conduct other cluster samples, let's say on the West Coast or in the South or in the Midwest. And so cluster sampling divides the large population into little clusters or areas, and then within those areas, you take a random sample of people from those regions to represent that region, which we can then extrapolate to the larger population. So I hope this third video was helpful. In the next one we're going to get into, we're going to talk about research designs.